Alright, so in this video we're going to continue to do calculations that involve concentration, but this time around we're going to get into a little bit more complicated multi-step calculations here. So for example 1 here, it says determine the mass of ammonium sulfide required to prepare a 1.40 liter solution of a 0.450 mole per liter ammonium sulfide solution. Alright, so first off I'm going to do a list of givens and then we'll talk more about a game plan. So because it says determine the mass, that means we have no clue what mass is. Okay, but we do know that volume here is 1.4 liters. And then concentration was 0.450. Alright, so because we're dealing with mass as well as concentration, there's two formulas that we're going to be using here. So the first one I'm going to write out is the concentration is equal to moles divided by volume. The reason being is because I've got 2 out of the 3 variables in that formula. And then the last formula I'm going to talk about is going to have to deal with mass. So our formula for mass is equal to moles times molar mass. Okay. So the issue here that makes this question a little bit more challenging is that when we look at the mass equation, we know we can figure out molar mass. Anytime they give you the identity of a substance, you are secretly given molar mass. So that we can figure out. However, we don't have moles, which is an issue because if you don't have 2 or more variables in a formula, you can't use that formula, at least not yet. Okay, so how we're going to figure out moles is since we have concentration and volume, we're going to rearrange this equation here to isolate for moles. So how we can do that is since volume's doing the dividing, I'm going to do the opposite of dividing, which is multiplying. And so the formula that I'm going to use to figure out my moles is going to be volume multiplied by concentration to give me moles. And once I calculate that, then I'll be able to figure out moles and plug it into this equation, which will allow us to figure out what mass is. So that's my game plan. I'm first going to figure out moles, and then we're going to calculate mass. So moles, we got no clue, and molar mass, that's going to be something that we figure out. Okay, now with molar mass, it's just easier to get that done and out of the way. So what's important here to be able to do is to convert the words into a chemical formula. So ammonium sulfide. Ammonium, that's one of our polyatomic ions, which is right here. So ammonium is NH4. Now sulfide, if it ends in IDE, then it's going to be an element. So sulfide is just the ion version of sulfur, and it has a 2- charge because it's in group 16 here. So a reminder, there is a trend that any nonmetal in group 16 is going to have a 2- charge. Any nonmetal in group 15 will have a 3- charge, and any nonmetal in group 17 will have a 1- charge. So let's get back to here. So ammonium, that's NH4, which has a +1 charge. Sulfide, that has a 2- charge. So we know that 1 minus 2, that does not equal 0, so we got to do crisscross applesauce and bring down just the numbers, not the charges though. Okay, by the way, whether you write 2 minus or minus 2, to me it's the same thing. For other instructors, they might be a little bit more sticky about that. However, for me, it doesn't matter if you write -2 or 2 minus. Both get the job done in this case. So like I said, in order to balance this, we're going to bring down the numbers. So I'm going to write brackets around my polyatomic ion, and then 2 because it's coming from the 2 minus on sulfide. And then for the 1, we could write a 1 after the sulfide ion. However, if you don't write a number, it's automatically assumed that there's a little invisible 1 there. Okay, so now what's happening is, since we have 2 ammonias, this has changed the total charge coming from ammonium to +2. So 2 minus 2 is in fact 0, so now this is a balanced compound. You always need to make sure you create a balanced compound before you start figuring out your molar mass. Okay, so now that we have the chemical formula, we can now figure out what the molar mass is. And as a quick reminder here, this is how you'd figure out molar mass. So molar mass of NH42S. So you can break it down in terms of the elements that you're using and how many atoms of each element there are, and then the molar mass of each element. So breaking this down into its elements, we have nitrogen, hydrogen, and sulfur. Now, for how many atoms, maybe I should write this out. Elements, atoms, molar mass of each element, and then we'll do a totals row, or a totals column. All right, so for the amount of nitrogen, keep in mind that with these brackets, this 2 applies to anything inside of the brackets. So we have 2 nitrogen atoms, and we have 2 times 4 hydrogen atoms, so 8 hydrogen atoms. And then for sulfur, since there's an invisible 1 right there, there's just 1 atom of sulfur. Now the molar mass for all of these, we're going to find on our periodic table. So nitrogen is going to be 14.01. Hydrogen is going to be 1.01. And then sulfur is 32.07. And all of these are in grams per mole. All right, so mathematically what we're doing to these numbers is we're multiplying the amount of atoms by the molar mass of each element there. So what we're getting, so 2 times 14.01 is going to be 28.02, and that's grams per mole. 8 times 1.01 is 8.08. And then we have 32.07 grams per mole. Now at the end of this, we're going to add everything up in our totals column. Okay, so 28.02 plus 8.08 plus 32.07 is going to give us 68.17 grams per mole. All right, so now that we have the molar mass, we can write that in. So 68.17. And we can keep on going on. Okay, so step 1 is going to be figure out how many moles we have. So we're going to be using moles is equal to volume times concentration. So for our volume, we put it as 1.40 liters, and our concentration was 0.450 moles per liter. So with the units, liters is in the top and the bottom, so they cancel out. And then multiplying those two numbers together, what we're going to get is 0.63 moles. All right, so that's, I'm not rounding off this number, that's what I actually got in my calculator. Now step 2, we're going to find mass, and that's using this mass is equal to moles times molar mass equation, because now we can use it because now we have an amount of moles. So mass is equal to moles times molar mass. So moles, that was 0.63 moles. And then molar mass, that was 68.17 grams per mole. So as you can see, moles is in the top and the bottom, so they cancel out. And when I multiply these two numbers together, what I'm going to get is 42.9471 grams. Now, remember, at the end of a calculation, we always round off to the appropriate amount of sig digs. So looking at my given numbers here, this number has 3 sig digs, same with this number. So reminder that leading zeros do not count as significant digits, but trailing zeros do. So when I say leading, I mean they come before a non-zero digit. When I say trailing, I mean it comes after a non-zero digit. So since both of them are in 3 sig digs, that's what my final answer has to be. So 1, 2, 3. My final answer is 42.9 grams. So that'd be 42.9 grams of ammonium sulfide. Looking at the next example, once again we're asked to determine the mass of magnesium chloride required to make 450 milliliters of a 0.250 mole per liter solution. Alright, so it's a very similar question to what we just did. We're going to follow the same steps. So we're still asked to figure out mass. And how we're going to do that is first we're going to determine molar mass because we were given the identity of the substance. Then we're going to find moles, and then we're going to find mass. So mass, we don't know. Volume, that's 450 milliliters. So just as a reminder, volume should be in liters for this particular formula here. So we do need to convert this to liters. Now, as we've said previously here, you can either use the metric conversion line or you can use unit analysis, which I've shown both here. So the metric conversion line, you write this out, you figure out where you're starting, and you figure out where you go to. Since liters is a base unit, and we're starting at milliliters, we'd just be going 1, 2, 3 to the left, or moving our decimal 3 to the left. With unit analysis, essentially what you do is you make sure that you cancel out milliliters by having 1 unit of milliliters in the top and the other in the bottom, and then since those cancel, you want to make sure you're left with liters. So if you want to recap on that, make sure to watch the video again. Another way that you can just remember how to convert from milliliters to liters is you could just say, just divide by 1,000. It all gets you the same answer in the very end. So if I divide by 1,000, that's going to turn this into 0.450 liters. Okay, and concentration 0.250 mole per liter. We don't know what moles is, and as of right now, we got to figure out what molar mass is. Okay. So with magnesium chloride, that's going to be magnesium and then chloride. So magnesium, if we look at our periodic table, notice how we're going to find it right here in group 2, and it likes to have a 2+ charge. So magnesium likes to be 2+ charge, and then chloride likes to have a 1- charge. So there's the 1- charge right there. And chloride is one of our group 17 ions, so that's why it's having a -1 charge. Okay, so 2 - 1, obviously that's not 0, so we got to do crisscross applesauce. So that's going to bring the 2 down behind the chloride, and we don't need to write a 1 behind magnesium. So now if we update that, since we have 2 chlorides, that's going to bring us to a total of a -2 charge coming from those chlorides. So we're going to have 2 - 2, which is 0, so it's a neutral compound, so now we're good to go. So I'll just create the little table we had. Elements, atoms, molar mass of each element, and then the totals. So we have magnesium, and in this chemical formula there's just one of them, and magnesium, if we look at that, its molar mass is going to be 24.31. So then that's going to give us a total of 24.31. And then for the chloride ions, there's 2 of them, and that molar mass is 35.45 if you wanted to check it out. There you go. Okay, so that's going to give us 70.9, and both of these are grams per mole. So adding them up, we're going to get 95.21 grams per mole. All right, now that we have molar mass figured out, now we are going to be finding moles. So this is what I labeled as step 1. So I'm going to start off with my equation. Moles is equal to concentration times volume, and we're taking 0.250 mole per liter, multiplying it by volume, which is going to be 0.45 liters. Our liters cancels out. And so that gives me 0.1125 moles. So I have not rounded this number off. That's actually what I got in my calculator. And now we're at step 2, where we're finding mass. By the way, when you're doing these calculations on your own, I don't expect you to write step 1, step 2. This is just to make your notes easy to read. I do expect you to write step 1 and step 2 out for the notes, But when you're actually doing your practice problems and your assignments, you don't have to write step 1, step 2. All right, so mass is equal to moles times molar mass. So moles, that was 0.1125. And then molar mass, that was 95.21. So moles cancels out. And I'm left with 10.7111. Number keeps on going on forever. Grams. Now for sig digs, looks like both of my numbers here are given to 3 sig digs. So then my cutoff line is going to be 1, 2, 3. That's 3 sig digs. So my cutoff line's right there. So 10.7 grams. And that's 10.7 grams of magnesium chloride. Now for these next couple of problems, we're going to be finding volume from mass and concentration. So again, these are a little bit more advanced calculations. But let's take a look at them. So we're going to determine the volume of sodium sulfate solution produced if 35 grams of the solute is used to prepare 1.24 mole per liter solution. So let's write out our list of givens. Volume, we don't know. Mass, that was at 35 grams. And concentration was 1.24 mole per liter. All right. So what's happening here is we're aiming to find volume. Now, for our volume formula, if I go back to concentration is equal to moles divided by volume, remember to isolate for volume, we need to first get it into the numerator and then isolate it. So since volume is doing the dividing, not moles, that's why I'm going to multiply both sides by volume. So volume times concentration is equal to moles. And now to isolate for volume, notice how concentration is multiplying volume. So then we got to do the opposite, which is divide by concentration. We are not going to divide by volume because if we do, we'll just get our original equation we had back up here. So now we have volume is equal to moles divided by concentration. Okay, so if we look at our list of givens, we're asked to find volume, but we don't have moles, but we do have concentration. So since we have two unknowns here, we can't use this formula. Instead, what we have to do first is we need to first convert mass into moles so that we can use this formula. And how we're going to do that is using our mass is equal to moles times molar mass formula, except for we're going to rearrange it to isolate for moles. So molar mass is multiplying moles, so the opposite is going to be division. So those cancel out. So mass divided by molar mass is going to be equal to moles. So I highly recommend that you use two capital M's to represent molar mass. Otherwise, if you just use one, it gets very confusing differentiating mass and molar mass if you only use one M for molar mass. Because a capital M and a little m look very similar, as you can see from my writing here. All right. So our game plan is going to be use this equation to figure out how many moles we have, and then once we have how many moles are in the solution, we're going to use this volume formula to figure out what the volume is. Okay, but looking here, just before we get started, we are given mass, but we're not explicitly given molar mass. We're kind of secretly given it by having the identity of the substance. So we got to figure out molar mass first. So molar mass, let's figure that out. So sodium sulfate, molar mass of, let's convert that into a chemical formula. So sodium is Na, and then sulfate, since it ends in ATE, that is your signal that this is going to be part of your polyatomic ion, so you need to find it in this table here. So sulfate is right there, SO4 2 minus. Now, since sodium is in group 1, it's going to have a positive 1 charge. And we know that 1 minus 2 is not going to give us 0, so we got to do the crisscross applesauce. So we're going to bring down the 2 there. And I am not going to put any brackets around sulfate because we only need one of them. And if you have only one polyatomic ion, you do not write the brackets. Okay, only write the brackets if you have more than one polyatomic ion in a chemical compound. All right, so element, atom, molar mass, total. So sodium, there's 2 of them. Molar mass is 22.99. So that's going to give us 45.98. Sulfur, there's 1 of them. Molar mass is 32.07. And then oxygen, there's 4 of them. And each of those has a molar mass of 16. So that's going to give us 64. And all of these are in grams per mole. So then adding those up, we're going to get 142.05 grams per mole, which we can throw in right here. Okay. So now that we have that figured out, for these types of questions, step 1 is going to be to figure out moles, because we have mass and now we have molar mass. So now we can figure out moles. So then moles is equal to mass divided by molar mass. So our mass, that was 35 grams. Molar mass, 142.05. And when we divide those two numbers, we're going to get 0.2463. Number keeps on going on forever. And since the grams cancels out, that gives us moles. If you're a little bit confused as to how the units are canceling out, I'm just going to focus on the units here, not worry about the numbers, but our first number, grams, and then I'm going to write this divide by sign a little bit differently than grams per mole. We're going to flip the divide sign into a multiply sign, because that's how you divide fractions, and then flip the fraction that comes after it. So see how grams is on the top and the bottom? That's how they cancel out, and that's how we're given moles in the end for our units. All right. So now we're going to do step 2, which is going to be to find volume. And the reason why we're finding volume now is because now we have moles, we have concentration, So we have everything we need for this formula. So 0.2463. I'm not rounding off this number. I'm using the entire raw number when I do this next calculation. And then concentration, that was 1.24 moles per liter. So then moles cancels out, and we get 0.19870. Keeps on going on forever. That's liters. Looking at my two given numbers, both of them have 3 significant digits. So then I count from the leftmost significant digit, 1, 2, 3. There's my cutoff line. And my final answer is going to be 0.199 liters. So I have 0.199 liters of my sodium sulfate solution. All right, for example 2, we're asked how many liters of a 0.6 mole per liter solution would contain 116.2 grams of sodium hydroxide. So very similar to our first question, we're going to have the same setup. So first, we need to find molar mass, then we need to find moles, then we need to find volume. So let's write out our list of givens and do all of that. So volume we don't know. Concentration 0.60, mass, that's 116.2, moles, no clue, molar mass, we're going to figure it out. So molar mass of sodium hydroxide. So sodium hydroxide is that. Sodium likes to have a +1 charge. Hydroxide likes to have a 1- charge. Hydroxide is one of your polyatomic ions, which is right here. So 1 minus 1, that is equal to 0. So that's a balanced compound. And I'm just going to write out the numbers here. So sodium 22.99 times by 1, 22.99. Okay, so that's for sodium. For oxygen, there's 1 of it. And the molar mass is 16, so that's going to give us 16. And then for hydrogen, we have 1 of it. Molar mass is 1.01. Oh, that should be 1.01. Then we're going to add all of this up. And that gives us 40 right on the dot grams per mole. All right. So now at this stage, we're finding moles. And we're using moles is equal to mass divided by molar mass. So 116.2 divided by 40 grams per mole. And that's going to give me 2.905 moles. So I haven't rounded off this number. That's actually what I get in my calculator. And I should write this in pink. Step 2. So we're using the volume is equal to moles divided by concentration and just plugging in our unrounded numbers. So 2.905 moles divided by, what was our concentration? 0.6 mole per liter. Moles cancels out. And that gives us, 4.8416 ... liters. And looks like this value is in 2 significant digits, whereas this one is in 4. So you always go with the least amount of sig digs. So that's why I'm going with 2 sig digs. So counting from the left, 1, 2, there's my cutoff line. So then my answer is 4.8 liters. And that's 4.8 liters of my sodium hydroxide solution. All right. Last but not least, we are going to be finding concentration from mass and volume. So for our first example here, it's asking what is the molar concentration, which is just same as concentration we've been talking about, of a solution made by dissolving 53.2 grams of calcium chloride in 5,000 milliliters of water. So concentration, we've got no clue. We're given a mass, 53.2 grams, and we're given a volume of 5,000. I already know that I need to convert this into liters so that it works in our concentration formula. So if I take 5,000 divided by 1,000, that's going to give me 5 liters. Okay, so looking at the formulas that we're going to have to use here. So concentration is equal to moles divided by volume. So looking at our list of givens here, we're looking for concentration. We don't have moles, but we do have volume. So we can't use a formula if we don't know 2 variables. So we got to use another formula to figure out moles. Okay, so that's going to be the mass is equal to moles times molar mass, but we're going to rearrange it to isolate for moles. So molar mass is multiplying moles, so I got to divide. What I do to one side, I do to the other. So moles is equal to mass divided by molar mass. So remember, you're secretly given the molar mass whenever you're given the identity of the substance. So since our substance is calcium chloride, that's how we know molar mass. Okay. For these types of questions, you're always looking for the molar mass of the solute, not the solvent. All right. So we're figuring out molar mass of calcium chloride. So calcium likes to have a +2 charge. Chloride likes to have a 1- charge. So balancing this compound, we're going to have CaCl2. Okay. So from the calcium, the molar mass of each calcium is going to be 40.08, and there's only one of them. With the chlorides, 2 times 35.45, which is going to give us 70.90. If we add those up, that gives us 110.98 grams per mole. All right. So now that we have molar mass figured out, now we can use this equation. So I'm going to say step 1, find moles. If you're wondering why I don't count finding molar mass as step 1, it's just because to me it's just a background process so I can get to the actual meat and potatoes of the question. So moles is equal to mass divided by molar mass. So 53.2 grams divided by 110.98 grams per mole. So grams cancels out. and we are going to get 0.4793. Number keeps on going on forever. And in subsequent calculations, I am going to be using the raw unrounded number. Step 2. Now we are going to be finding concentration, which I'm going to abbreviate as CONC. So concentration is equal to moles divided by volume. So 0.4793. So I'm using the unrounded number that I got in my calculator to do this next calculation, divided by 5 liters. That's going to give me 0.09587. Number keeps on going on forever. It's moles per liter. Looking at the numbers given, so this is 3 sig digs and this right here is 4 sig digs, so you always go with the lesser amount of sig digs. So 3 sig digs it is. We start counting from the first significant digit, which is here. 1, 2, 3. There's my cutoff line. So 0.0959 moles per liter. So that is the concentration of our calcium chloride solution. With example 2, it's going to be exact same process. So molar concentration, we don't know. So what is the molar concentration of a solution made by dissolving 0.1031 kilograms, so that's a mass, of ammonium sulfate in 1.25 liters. All right. So looking at mass, I know I need it in grams so that it can work in this formula here. So we need to convert it. So you have 2 options with conversions. You can either remember the conversion factor, or you can just write out the metric conversion line. So this thing. So I highly recommend creating some sort of memory device or mnemonic device to help you remember all of the prefixes. Okay, so kilograms, where we are starting is K. If I want to go to grams, because grams doesn't have a prefix to it, it's going to be our base unit. So then we're moving our decimal 1, 2, 3 spots over to the right. So if I write that out, 1, 2, 3, this is going to be, and I'm going to have to move this. Hang on 1 second. There we go. Beep. So that's going to be 103.1 grams. Okay, so alternatively, what you could do that would give you the same result if you didn't want to use this is you'd have to memorize that you just times kilograms by 1,000 to get to grams. All right. Since I know I need to figure out molar mass, I'm just going to write it here. So we're working with ammonium sulfate. So ammonium, that's NH4, that's one of your polyatomic ions. Sulfate is SO4. Again, another one of your polyatomic ions. Ammonium has a +1 charge, sulfate has a 2- charge. We gotta do crisscross applesauce, so that's 2. Okay, so with the nitrogens, we have 2 of those, and that's at 14.01, which is 28.02. Hydrogen, there's 8 of them, times 1.01 8.08. Sulfur, there's 1, 32.07. And then oxygen, there's 4 times 16 for the molar mass, which is going to give us 64. So adding those all up, and we're going to get 132.17 grams per mole. Okay, what color did I use? I used, oops, blue. Oh well, it's going to be slightly different color coding. Alright, so step 1. So this is where we're going to be finding moles. Always start off with your formula and then plug in your numbers. Alright, so mass 103.1. Grams, molar mass 132.17. Grams is going to cancel out. And for our moles, that is going to give us 0.7800. Number keeps on going on forever. Moles. Then step 2. We're going to be using concentration is equal to moles times volume again. So remember, I'm using the raw unrounded number in my calculator in this next calculation. Divided by, we had 1.25 liters. So concentration is going to be 0.6240. Number keeps on going on forever. Mole per liter. And looks like this number is in 3 sig digs, this number is in 4 sig digs. Remember, leading zeros do not count, but the rest of these do. So this is going to be in 3 sig digs. So 1, 2, 3. 0.624 moles per liter. Final answer. So that's 0.624 moles per liter is the molar concentration of our solution of ammonium sulfate.